first definition is White's stationary process. The second is independent increment process. The third is Markov process. The fourth is normal process. Fifth is strict sense stationary process. Sixth, white noise. Seventh, mean ergodic process. Eighth is martingale. So the question goes like this. The first one is White's stationary process. A stochastic process is called as White's stationary process if its mean is a constant and autocorrelation is a function of time difference. WSS only uses mean and autocorrelation. In practice, they are much easier to get than the second order density. Based on the mean and the autocorrelation function, we can do many things already. We can do a state estimation, parameter estimation, and prediction, and in mean square sense. In mean square sense, the communication application is, in most cases, we do not care too much on a specific value of stochastic process. We pay our concentration to the power of signal. The independent increment process. The independent increment process means x of t1 minus x of t2 and x of t3 minus t4 are non-overlapping intervals and are independent. So far we have seen that the process, the Poisson process, the random walk, and the Wiener process are independent increment process. This seems that the independent increment property is somehow related to Markov process. Let us discuss this factor more in the later part of this assignment. The third one, the Markov process. We say that the process xt is a Markov process if the past has no influence on the future when the present is known. So far we know that the Poisson process, Poisson impulse, and semi-random telegraph, random telegraph, and random walk, and Wiener process all are Markov process. In the real world, many processes have Markov property. The binary transmission in the early homework is a discrete time stationary Markov process. The fourth is normal process. A process of xt is said to be normal if the random variable xt1, xt2 continual x of t of n are jointly normal for any n, and for any t1, t2, t3 dot that is continual tn. That is f of x, x1, x2, x3 continual xn, and t1, t2, t3 continual tn, that is equal to 1 upon root over 2 pi to the power n determinant of c e to the power minus 1 by 2 x minus eta to the power t c inverse x minus eta, where x is equal to, x is a vector of x1 to xn, and capital X is a vector of capital X of t1 continual capital X of tn. Eta is equal to expectation of x, and c is equal to expectation of x minus eta into x minus eta transpose. The statistics of a normal process is completely determined in terms of eta t and autocorrelation are t1, t2. In general, eta t is a function of t. In this course, we have classified Wiener process as one of the example of stochastic process, and we have classified the normal process, a property of stochastic process. That is, we treat normal process as a larger class of stochastic process, and we treat Wiener process as a specific example. Fifth, strict sense stationary process. A process is said to be strict sense stationary process if its statistics is not affected by a shift on time axis. SSS process requires f of x1, x2 xn, t1, t2 tn is equal to f of x of x1, x2, x3 t1 plus eta plus t2 plus eta plus tn plus eta. This condition is very hard to prove, and hence therefore we are just remembering this condition. The white noise. For Wiener process Wt, if we wish to discuss its derivative, v of t is equal to dw by dt. We have estimated value of v of t, that is equal to e of dw by dt, that is equal to 0. R of t1, t2 is equal to alpha of delta of impulse t1 minus t2. The Wiener process Wt does not have any derivative. We use v of t is equal to dw by dt. just as a notation where we need to do the further discussion instead of vt of dt. We use dwt. Wt is a continuous probability is a continuous function with probability 1. It has different dw by dwt. Vt is equal to dwt by dt is Gaussian white noise with zero mean and impulse autocorrelation function. We wish to define more general white noise with zero mean and impulse autocorrelation function. The seventh, a stochastic process. Xt is said to be a mean or ergodic process if limit t tends to infinity 1 by 2t in integration from minus t to t x of t dt is equal to estimation